So hello everyone, this is Akshay here and welcome back to the another great day of our GFG POTD stream. Today's question name is Geek, Village and Wells. So if you have read this question, able to solve it, well and good. And if you have not read the question, not able to solve it, then let me tell you that this question is exactly similar to the question we did in day 163 Nights in the Geekland with the BFS technique, right? So again, we will do the same thing because you can clearly see what it's written is that the person is allowed to move only in four direction, left, right, up and down. And this means they have been given the coordinates, right, and the person is not allowed to move out of the group. Okay, so what the input test case is saying is that H represents the house, W represents the well, right? So we need to find the minimum distance that a person in the house should travel to take out the water and carry it back to the house, right? So suppose this is the well, right? So the nearest for this house, let's say for this house, the nearest well would be this, right? So it would take one distance to go to well and one distance back to come back to its house again. So that's why it is written two here, right? Let us dive in for some of the test cases as well. So if you see this house, let's say this house, right? So what this the person at this house will do, maybe it can go down and then it can go left. So the distance travel will be 2 and then it has to come back. So 2 into 2 will give you the 4 reason, right? The same path it will take, that because that's the minimum path, right? Similarly for rest of the cases as well. So again, I'm saying that it's the purely DFS based question, and if you were with me on this day 163 of the solving this nights in Geekline, then you definitely would have clicked this question, and the same code will be there for the BFS algorithm, right? Also, you may refer to that video for how the BFS boilerplate is working, but rest assured, I will teach you again as well, but with the minimum information this time, right? So what we have to do, that instead of moving from house to each and every well, just push the coordinates of well into a queue, right? Into the queue, and then we will traverse from well to each and every houses, right? And the traversing is take care by the four coordinates, just these four coordinates, right? So in the queue, what we will do is that we will iterate for each and every cell, for every cell, let's say iterate for each and every cell, and we will check that if also we need a visited array of n cross m, right? And whenever there is this we found a cell as w, then we will mark this as true, right, for the entry cell as w, and we'll push these coordinates, let's say I comma j, then we will push these coordinates into the queue, right? And as soon as we have these coordinates, for this case we will have 1 comma 1, right? Then we will keep traversing from here. So how the traversal will look like is, let me explain you. So h w h h h and h, how the traversal will look like. So what is BFS actually? So let's say you have this a, right, and the neighbors here are given as b, c, d and e, let's say, right, the nearest neighbors b, c, d and e. So what happens, first of all, the root node will get pushed into the queue, and when it the processing has happened, whatever the requirement is there, then it pushed the neighbors. So let's say b, c, d and e, the neighbors will be pushed. And let's say b has the neighbor now g, f, and then c has the neighbor of, let's say, h and I, right? So now when the b will process, then what it will do, the g and f will be pushed, the immediate neighbors of b, right? Then again, according to the, will keep on popping in the queue, then the c will move out and the neighbors of c will be pushed, that is h and I, right? If similarly d will have no neighbors, let's say, then it will be processed and nothing will be pushed. Similarly, E will be processed, and then this GHI. And that's the reason why this BFS is also known as level order traversal. If you see, then first what we did, we this was the first level, this was the second level of our traversal, and this is the third level of neighbors that we traversed in, right? Okay. So similarly, the case will happen. So we are at this point W. So the level order, let's say, is moving in first up, let's say then right, and then let's say down, and that's left. So let's say this is the hierarchy this is following. So it will go up, right, and it will keep on going, moving upwards until it go out of bounds. So it will see that there is nothing left, so it will retrace back, right? So it will come back to its parent call, it will come back to its parents call, and then it will move right. It will then right, from right it will go again up, right? It will come back to its parent call, and then will again it will try to move right, but then again right also there is no neighbor, so it will now move down, right? For down, it will again go up and it will see that the okay, this neighbor is already visited. So whenever you are traversing, you have to keep marking the visited as well. So from this edge, what all direction it has, it cannot go up nor it can go to the left, because the w is there. It will only move to the cells which is not w, right, and not equals to n, not equals to n, and it will not move to the places where the mark it is marked as false. So since we have started from w, so it is marked as false. So from this edge, the only option will be moving will be here, right? Then it will move to this point, then it will move to this point, and again at this point and this point, right? And while we are moving this, we have to mark by the distance, right? So this will be marked as distance 1, right? And similarly all the cases. Okay. So when the traversal is happening, so if you just keep on incrementing the distance, then you will see that this will be 1, this will be 2, this will be 3, 4, 5, 6, and 7. But that is not the case, right? It should not happen like this. So that means we need, first of all, we need a pair structure not only to store the coordinates, but now we'll have to store one more parameter, let's say C, which will point to the distance, right? And initially for all the cells, it will be pointed to 0. And now what will happen? That now it would be incremented by 1, right? And similarly this would be incremented by 2, and similarly all the things will happen, right? So okay, let me show you a clean dry run again for this particular test case as well. So I know the video is getting long, so let me write it and then resume it. Okay, so first W was pushed into the queue, right? Then it will visit all its 4 neighbors and mark it as true. So it will visit all the 4 up, down, left, and right. So it will mark as true, marked as true, marked as true. Since we have made the one move, so it will the distance will be as of now marked as +1. Let's say +1, +1, and +1, right? And when it pushed the new coordinates, right? So let's say it pushed the coordinates of this, say 0, 1, right? So what it will do, it will push 0, 1, 1. That is, you have already considered the one distance. Similarly, it will push rest of the edge. So let's say if it has pushed this edge, then uh, uh, it would be 1, 2, and the distance is 1. Then again, this edge would be pushed. Let's say the down one, so it would be 2, 1, and again the distance. And again this left edge, so it would be 0, no, it would be the coordinates will be 1, 0, and the distance again would be 1, right? So what will happen next is, so this will be now processed, this first edge, this edge will be processed, and it will again move left and right, the only possibility it has, right? It cannot go up and down because down is already visited. And now using this as well, using this is +1, the +1 which he has, it will now appoint +1 to which this third parameter, and the it will have +2. And then again similarly it will have +2 here, right? Now it cannot move any further and it has no neighbors as well, which is not visited. Then again this node will be processed and it can only move down. So since it has +1, it will do +1 again its current distance, and the number pointed here will be 2, right? Okay, so it cannot move in any any further direction, so it will be now debarred, right? Okay, so now this 2 comma 1 comma 1 for this coordinate. So again it can move, it cannot move right because this node has been already visited. It will just move left and will give +1 to its current distance, that is it will be +2 again. Yes, so now this edge cannot move in any of the directions. Then again this is processed and then we will come at this last edge, but you can already see that this has no neighbors to process and move on to. So you can clearly see what are the values, just write the value. So it is 2, 1, 2, and then 1, and for this it would be 0, 1, then again 2, then 1 and 2. So you can see this is your distance from the well to each and every houses, but you need to return the 2x of the distance, right? Because you have to come back from house to well, from well to house, right? So it would be just double the distance. So 2, 4, 2, 4, then 2, 0, and 2, and then 4, 2, and 4. You can see this is our answer, right? So when we have this matrix, then we will have, after the DFS we'll have this matrix, and then just after we have to some if statement, that if it is if it n, then mark it as 0 at set by the question. If it is w, mark it as 0 again at set by the question, and for rest of the cases just multiply it by 2, right? Star equals to 2. Okay, so again we will not do the live coding here because we have done this BFS multiple times. The same boilerplate will happen, boilerplate code will be written. So let me do that for you and then we'll proceed ahead. Okay, so that's the code here. Let us start with the point. We understood that why we need the two coordinates. We have already seen that I and j is always required, but the third parameter is also required here just to maintain the current distance. Else I would have showed you the problem, right? If you do not maintain the third parameter, then the BFS traversal will update the values very vaguely. You will not get the right answer because this would be the path of your traversal, right? Okay. तो चलते हैं वापस से. So we have a result of 2D array in which we have to store the answer, and we are marking it with that integer dot max value. So why integer dot max value? You can just mark it with just one digit more than this 10 power 3 also, and it will work, right? You can even replace it with 10 power 4 and it will work for you. Okay, so we have a boolean visited array just to maintain that whenever the node is visited, we will not have to visit it more than once. So if the current cell is w, then we are marking it as true, and then marking for the current entry as 0, because the question said whenever you have w and n in your array, then you have to return 0. Your answer would be 0, right? And then we are pushing the source root node, let's say, into the queue, and for each and every root node we are now iterating for all the 4 directions. For iterating for all the 4 directions, we have made a 2 linear array. You know how it is done in the knights and Geek lines also. A knight can move 8 in 8 direction, right? वो chess में जो एक घोड़ा होता है, it can move in 8 direction, and that's why we made an 8 entries of one linear array has 8 entries. Similarly, dx and dy. Okay, so for each and every entries in the queue, we just have to pull the current entry and then have to move in the all the 4 direction, making the new coordinates new x and new y. And what we have to check that it should not go out of bounds, the new coordinates, the visited, it should not be visited, and it should not be equals to n, because it has said that whenever you have n, that means that you have been in a prohibited area, you cannot pass that area, right? If that's the case, if that is not the case, if it is not visited and if it is not in and in the bounds, then we have to traverse ahead, right? And since we are traversing ahead, we need to push it in the queue, mark it as true, and then this third parameter is now helping us, dot p dot c dot 1, right? Because it is storing the current distance of the BFS traversal, right? It is storing the level wise distance, right? This w visited the immediate first level, and it stored the distance, okay, that +1. Whenever the next neighbors visited to the another vicinity in the neighbors, then it will just increment +1 to that current level. Okay, I hope you're getting the point. It's just basic DFS, and I have taken much more of time on this particular thing. So we have the nested for loop again, as said by the question, that if it is equal to dot or n, then you have to mark it as 0. And what is this case now? This is the case where you will not get an answer. So let's say this second test case, you have this here, right? So this w will never be able to reach this edge, right? Because you can see it can only move in 4 directions, right? So while moving, let's say it move up, and then it keeps on traversing, it reached here, but it cannot penetrate this n, right? Similarly, this h also cannot penetrate, and this h at the first 0, index will never be able to reach to well. And that is why we are checking, since we have filled all the answer array with integer to max value. Again, I'm repeating, you can just fill it with 10 power 4 as well. If that's the case, then you have to say that answer is not possible, and in rest of all the cases you have to multiply it by 2, because the person at a particular house can reach a well and it has to come back also, right? So definitely the distance star 2 will be an answer. Okay, so what would be the time complexity? The time complexity of a BFS is we are visiting each and every cell once, so it would be n cross m. What would be the space complexity? We are using a queue, and the maximum call will be made for each and every cell. So n cross m for the queue, n cross m for this boolean visited array, and n cross m for the result. So it would be 3 star n cross m. And okay, yesterday question was actually a good question on segment tree, and I was also like not able to do this. Yesterday was a very hectic day for me. So sometimes when you're on a project, so software developers seems to be a very good role, but when you're on a project, it can be a boon to you as well. तो ठीक है, मिलते हैं कल के पीरियड स्ट्रीक में डे 189 में, and yesterday segment 3 I will definitely make that video up in this coming weekend. I really needed this weekend. ठीक है, तो तब तक के लिए बाय बाय, टेक केयर, कीप लर्निंग एंड टेक केयर.